Hi everyone, welcome back to the second half of this chapter where we're going to talk about global climate change. Here we can see a picture in Alaska, which Alaska is really feeling the effects of climate change already. Much of the land in Alaska is permafrost or it is supposed to be permanently frozen. And as that permafrost is melting due to global warming or climate change, what's happening is the land is becoming unstable, and we see structures that are falling down. So we're going to talk about a couple examples of that. We're going to talk about what exactly is climate change and global warming, why we know it's happening, and why it's so important. So the first thing is to understand the difference between climate change and global warming. So climate change is driven by global warming. The entire planet is getting hotter over time, and other aspects of climate are changing as a result. So it is happening. The science is very strong on this. So if we have a hypothesis that says human activity is adding greenhouse gases and heating the planet, right, that is kind of the essence of climate change. We've added a bunch of greenhouse gases to the atmosphere, and because of that, the planet is heating up. And we know this from a couple of very basic observations. One, greenhouse gases absorb infrared heat, which we talked about previously. As solar radiation comes into the planet, it's re-radiated as infrared. Some of that is trapped by our greenhouse gases, and we need that to happen in general, or otherwise the planet would be uninhabitable. But we've added more greenhouse gases, so now more of that infrared is being absorbed than was previously. Observation two, there are more greenhouse gases in the atmosphere now than there were before. And that's a really easy thing that we've been measuring, right? We're able to take atmospheric measurements, see how much greenhouse gases is there, and we can definitely see that we have a lot more greenhouse gases in the atmosphere now than we did previously. And observation three is the planet is heating up, right? So we know these very basic things. We know that greenhouse gases absorb infrared. We know that we've added more greenhouse gases to the atmosphere, and we see that the planet is heating up. The science behind just the fact of that the planet is warming is pretty simplistic and very, very, very strong. And again, this is a little pie chart showing you that there was between 1991 and 2012, there's about 14,000 peer-reviewed climate articles. Only 24 of those reject global warming. There is kind of a narrative out there that basically scientists are squashing debate. Scientists love debate. I'm friends with a lot of climatologists. They love to debate each other about things. It is not that the kind of anti-climate change argument is being squashed. It's that there really isn't any scientific evidence for it. And so, what are our two main sources of greenhouse gases that we're adding to the atmosphere? The first is carbon dioxide, which is the one that we probably hear the most about. It's released anytime we burn anything with carbon in it. So that includes all fossil fuels. We get a lot of coal from coal when we burn it in power plants. Coal is kind of falling to the wayside. Not so much due to environmental regulations, but because we have discovered very large natural gas deposits that are now available through hydrologic fracking. Natural gas is a cleaner burning fuel than coal, but still adds greenhouse gases. It's not a clean burning fuel, it is cleaner than coal. We also release carbon dioxide when we deforest. Forests are very large carbon sinks. They hold lots and lots of carbon, and when we pull out all of those trees, we lose that carbon storage. And the second main source of greenhouse gases is methane from decomposing plant matter. But this is mostly from livestock gas and droppings. We have an incredible amount of livestock on this planet, way more than we ever did before. Meat eating globally has gone up. It's a sign of affluence if you're able to eat meat more regularly, and meat has become a lot cheaper. And so basically, cows produce a lot of gas, mostly actually from burping, and this contributes a lot of methane to the atmosphere. The other way that we contribute methane is from that melting permafrost that I showed you before. So that permafrost contains a lot of methane. When it melts, it releases that into the atmosphere, and it causes this weird feedback loop where you're also then increasing the global warming, melting more permafrost, releasing more methane. Carbon dioxide is the one that's normally addressed with kind of climate change policies. And that is because once you put carbon dioxide in the atmosphere, it stays for a really long time. It has a very long residence time. Methane has a much shorter residence time, so if you cut back on methane, it will leave the atmosphere pretty quickly, but carbon dioxide is considered to be the more potent one. And so, again, we can see that there's more carbon dioxide, which is a greenhouse gas, in the air. We've measured it. Here is a NOAA observation station on Mauna Loa in Hawaii, and we look at the atmosphere and go, okay, we've taken these measurements, definitely more carbon dioxide in the air. And when we look at global warming trends, one of the arguments that also gets presented is, hey, the planet used to be a lot warmer. And that is true. The planet did used to be a lot warmer. If you look at the top here, you can see that several million years ago, the planet was definitely warmer, right? It's been generally kind of cooling overall, and that's true. But we weren't around for a good portion of this. If you look in the past thousands of years, right, the climate was also kind of unstable, but it normalized about 10,000 years ago, which I'll talk about in a second. But if we look at the past 1,000 years of climate, what we see is we have a fairly regular climate, and then we industrialized, started adding lots of greenhouse gases, and this spike here is the big concern. This kind of all of a sudden shoot up of temperature in a very short amount of time. Most of this change that's happening over millions and millions of years is very slow. This change is happening really fast. And also what I want to point out, and you're going to watch a video about this as well, is that 10,000 years when the climate stabilized, that was when we figured out agriculture and settlements. That was when human beings stopped being primarily hunters and gatherers and started settling. And so these climate patterns, these predictable climate patterns, we have become very dependent on as the human race. And so it's really us that's going to suffer from climate change. And so again, we're concerned with that short-term warming trend. We were steady for 10,000 years, and we figured a lot of really great stuff out that we depend upon. The 14 hottest years in human history have all been since 1998. That's actually 15 now. This should take 2016, hottest year on record. So consistently we are breaking records. And it doesn't mean that everywhere that year is hotter on average, but globally the temperature is hotter than the previous year. And these are beyond natural fluctuations, right? We know what natural fluctuations in temperature look like. These are beyond that. And again, just because it's cold somewhere doesn't mean the planet isn't heating. So if we look at an average from December 2014 to February 2015, this is, the reds are operating above normal. The blue is below normal. And you see, yes, part of the United States was colder, but globally there has been an increase in temperature. So again, we're not talking about specific weather events. We're talking about climate overall. And so how do we understand long-term climate? How do we have this information? How do we know what the temperature has been like on our planet for such a long time? The first is thermometers, right? That's a very self-explanatory one. We have data for only about the last 120 years. We've been taking consistent temperatures all around the planet for about 120 years, though, so we have some really good data there in the short term. The next way we know is dendrochronology, which if you look here, there's a picture of tree rings. People can look at tree rings and tell things about the seasons and the temperature and how much precipitation they got, and it is incredibly accurate, and it goes hundreds of years back. Dendrochronologists are really good at this, and they know that they're accurate because they test it up from that last 120 years where they have actually measurable data. Beyond that, we go to oxygen isotope analysis. Basically, we sample into very old ice and coral reefs in order to analyze what the climate was like then. And that can go thousands of years back. And then after that, we used something called fossilized pollen analysis. Here's a picture of some fossilized pollen. We're able to look at that pollen, understand what the climate was like, and that goes millions of years back. So one of the major consequences of climate change and global warming is rising sea levels. And so there are two things that contribute to rising sea levels. First, as temperatures rise, the ice melts and there's more liquid in the ocean. And that's kind of the very intuitive one. Here is a picture of surface melting in Greenland from the Greenland ice sheet. So more water's in the ocean, oceans are going to rise, and that's the one that people normally think about. The sea levels, though, are already rising more dramatically from something called thermal expansion. So as you heat water, or anything really, it expands. And so globally, you have this giant ocean. So much of our planet is covered by water. If that's even just getting a little bit warmer, it is going to expand and cause a lot of sea level rise. This picture down here is kind of an artist's imagination. If all of the polar ice melted, what would San Diego look like? And you can see it would be dramatically different. Right, large parts of the main part of the city. Mission Bay is not really there anymore. Now we have Mission Estuary. So large parts of our city would disappear. And again, we can look at melting ice, right? So we can look at ice sheets. Here is one just north of Greenland. And so ice sheets expand and contract through seasons. So in the winter, they get bigger, and then in the summer, they shrink. But over the years, we can see that between 1979 and 2000, right, the average length of the ice sheet extended all the way to here. 2005, it was here. 2007, it was here. And so we can very, very clearly see these ice sheets retreating. You might have some years where they gain a little bit of ground, but overall, long term, and remember, climate, we're concerned about long term trends, not short term weather events. We can see that these things are retreating. And so, additionally, an aspect of global climate change, so it's going to affect climate. Remember these average conditions. When we get increased temperature, we're going to get increased evaporation, and therefore we're going to get more precipitation. So as the planet warms, more water is going to evaporate, be thrown into the atmosphere, and overall we're going to get more rain. And some people might say, well, that's great because a lot of places have droughts and we're going to get more rain. But some places are actually going to get much drier. Some places are going to get much wetter. There's going to be flooding, and it's really, really hard to predict. Some places are going to get more snowfall, but also this increased evaporation results in stronger hurricanes and tropical cyclones that can potentially do a lot more damage. And again, some places are going to get drier. We are shifting these very predictable climate patterns that we have gotten used to as a human race over the past 10,000 years. So temperature patterns will change, pressure changes, winds change. It's going to be very, very hard to plan out agricultural systems with this rapidly changing climate. And again, there'll also be effects on wildlife and ocean ecosystems. And again, that agriculture is the one that's going to affect us pretty hard. In addition to increased storms, and for those who live on the coast or on small islands, you're going to watch a video about climate change refugees after this. It's going to have a really, really great effect. And also there's more feedback loops that we might not fully understand yet. I talked about that example of the feedback loop of permafrost where it releases methane, causes global warming, and then that effect makes it melt more permafrost, causing more global warming, so these big feedback loops. Climate is incredibly complicated, especially when you're talking about global climate. So we can model and predict what's going to happen in certain places, but these complex feedback loops we might not yet fully understand, and so it's going to be hard to predict exactly what will happen in certain places. So the wet is going to get wetter, the dry is probably going to get drier, but overall we're going to get wetter. This is in Washington State, where due to some heavy rains, they're experiencing some landslides. This picture is from 2014. And right, we have built in places where we are used to predictable climate patterns, where we feel like we're going to be secure, but when we change all of this stuff, it's going to be much harder to adapt. there are a couple non-human climate change factors, things that can affect climate. The first one is volcanic activity. Large enough volcanic activity will have a actual cooling effect in a lot of places. It'll block out some of that sunlight. We have orbital changes that happen called Milankovitch cycles, where sometimes we are orbiting a little bit closer to the sun versus a little bit farther away. Also, the sun itself can have changes in solar output, solar flares that can affect us. But they are not responsible for the current rate of change. Like these non-human climate change factors are relatively small. We can document them. We can see how much they change the climate, and it is very, very, very little. And again, it's happening. I swear, I'm not lying. There's no conspiracy. You're going to watch a video after this that is shows how Republicans and Democrats have talked about climate change over the past 15-ish years or so, maybe a little bit farther back than that. The video is obviously geared towards Democrats. Democrats tend to be on the side of let's do something about climate change. Republicans do not. I'm not showing you that video as a pro Democrat or pro-Republican argument. Basically, I'm showing you that video because climate change has become this very, very controversial thing. The current administration has just pulled out of the Paris Climate Accord, which almost every country in the world had signed. And basically, this used to not be a bipartisan issue, right? Republicans and Democrats used to agree that climate change was a problem and we had to do something about it, and that it was happening. But it has since become one, but it was not always that way. So you're going to proceed on to those couple of short videos, your last exercise for this module, and then your quiz.